You know that little label on your hairdryer or your phone charger? The one that says 220 volts? It seems pretty simple, right? But the truth is, the electricity coming out of your wall is constantly changing. So in this explainer, we're going to figure out what that number really means. And trust me, the answer is way cooler than you think.
Okay, let's really get into this. You've seen this on pretty much everything you plug in. It says 220 volts, or maybe 110 depending on where you are in the world. But here's the catch. The AC stands for alternating current. That means the voltage is not constant. It's actually swinging up and down, back and forth, all the time. So what single number could that possibly be referring to?
So to get to the bottom of this, we've got to quickly remember what AC actually is. It's totally different from direct current, or DC, which is what you get from a battery. DC is like a steady stream, always flowing in one direction. But AC? The electrons are literally doing a dance, constantly switching directions, sloshing back and forth in a perfect rhythm. And that periodic change? That's the key to this whole thing.
Now, the first thing you might think is, okay, if it's always changing, why don't we just take the average? And that sounds like a perfectly reasonable idea, right? But it actually leads us to a really, really weird problem.
Just think about that wave for a second. It goes up into the positive, then it comes down and does the exact same thing in the negative. The top half of the wave is a perfect mirror image of the bottom half. So when you try to average those two halves together over one full trip, what are you left with?
Yep, a big fat zero. Mathematically, it's true. The average voltage of one complete AC cycle is zero because the positive part completely cancels out the negative part.
And this is where it gets confusing. If the average is zero, it kind of sounds like you didn't use any power at all. You know, I don't think your power company would be too happy with that argument. Clearly, our stuff works. Your toaster gets hot, your lights turn on, so a simple average just isn't telling us the real story about the power of AC. We need a smarter way to measure it.
And that smarter way, well, it's the hero of our story today. It's a special kind of average that completely solves that zero problem and gives us a real, useful number for AC power.
It's called the RMS value, which stands for root mean square. The best way to think about it is this. RMS measures what the AC voltage actually does. It tells you its effective power. It answers the question, if I wanted to get the same amount of heat or light using DC power, what voltage would I need? It's all about the equivalent power.
And the cool part is, the name root mean square literally tells you how to calculate it, just backwards. First, you take the AC wave and you square it. That instantly makes all the negative parts positive. So now you have this bumpy wave that's always above zero. Next, you find the mean, or the average of that new all-positive wave. And finally, since you squared it at the beginning, you take the square root of that average to get it back to the right scale. Root, mean, square. Simple as that. And there it is! Mystery solved. That 220-volt number on your appliance? It's not the peak, it's not the average, it's the RMS value. It's the effective, work-doing, power-equivalent voltage of the AC in your walls.
Okay, but that kind of brings up another question, doesn't it? Why is AC a wave in the first place? Why all this back and forth business? Why isn't it just a nice steady flow? Well, to get that, we have to look at how it's born.
I mean, just look at the difference. DC is a flat, predictable line. Boring but reliable. AC, on the other hand, is this beautiful, rhythmic sine wave, just gracefully swinging between its positive and negative peaks over and over again.
It's this endless cycle, rising up, falling to zero, diving down, and coming back up. That is the very nature of AC. This wave-like behavior is exactly why we need a special tool like RMS to make any sense of its power. So where on earth does this perfect wave come from?
That perfect sine wave is no accident. It's not a choice. It's the natural, inevitable result of the incredibly brilliant way we generate almost all of the world's electricity.
It all boils down to this fundamental law of physics from Michael Faraday. Now, don't let the fancy words scare you. All it really means is if you move a magnet near a coil of wire or a coil of wire near a magnet, you create electricity. That's it. This effect is called electromagnetic induction, and it literally powers our entire civilization. So picture a giant power generator. At its core, it's really just a big coil of wires spinning inside a magnetic field. It doesn't matter what's doing the spinning. It could be wind, or water falling through a dam, or steam. Some outside force creates this rotation, and that simple rotation is what generates our electricity. And here's the magic connection. That smooth, circular spinning motion of the coil directly translates into the smooth, wave-like rise and fall of the voltage. The AC sine wave is literally an electrical picture of the physical rotation happening inside the generator. It's beautiful.
All right, so we followed the thread all the way from the number on the plug to the spinning heart of a generator. Let's take a step back and put all the pieces together one last time. This is the perfect summary right here. DC comes from things like batteries, it's constant, it flows one way, and it's perfect for our phones and laptops. AC comes from those big spinning generators, its voltage is always changing in that sine wave, and it's the undisputed king of our power grids.
And there you have it, the whole story in a single sentence. The number on your wall is an RMS value. We need that RMS value because AC is a wave that averages to 0. And it's a wave because it's born from the simple, elegant rotation inside a generator. It's just a perfect chain of logic.
But before you go, there is one last really fascinating detail. That 220-volt RMS value, that's the effective voltage. It's not the highest the voltage ever gets. In a 220V system, the voltage is actually peaking at over 310 volts every single cycle. That's nearly 41% higher than the number on the plug.
And that leads to one final, huge question. If a 220-volt AC line is actually hitting peaks of over 300 volts, that makes it way more dangerous than a simple, steady 220-volt DC line. So why on earth did this more dangerous type of electricity win the Great War of the Currents to become the standard in all our homes? Well, that is a fantastic story for another explainer.